Okay, so let's start. Today's is gonna be about experimental design. So it's really fun, like inquiry slash build event science. So yeah, I'll just get started. Okay, so what is experimental design? It's basically a event where you have to design, conduct, and report the findings of an experiment based on a topic given. The topic is the same for everyone, and then in like some slides, I'll show you like example topics, but they'll give you materials, and you basically have to make like a write up and conduct an experiment. So like there's three steps to it. First, you design an experiment with the assigned topic, conduct that experiment with the given materials, and then you report on that experiment and you complete a write-up that is divided into sections, and I'll get into the sections after. Okay, so the rules. You can use one timepiece, one linear measuring device, and one non-programmable, non-graphical calculator during 50 minutes. So you can use basically whatever like measuring device you want, but other than that, you cannot use any more materials. You're not allowed to bring any paper or cheat sheet into the event. So there's two sections in the write-up. You can see in the rubric. I can actually send you guys the um, like a PDF of the rubric. Okay, there. And so you can see how there's two sections. There's one section for the design and the construction of the experiment, and one of the data analysis and conclusion. Okay. So example topics would be like properties of water, osmosis, capillary action, or like biology. So these are like some example topics that they'll give, and you have to make an experiment based on that. So you must have a rough idea on example topics, like research a little bit before entering the test. Otherwise, when you like go into the test, you'll have like no clue what to experiment on. Like if you don't know what capillary action is, you won't be able to do it. So it's okay if you don't know the answer because I didn't explain what it is. But what do you think capillary action means? And you can type in the chat. It's okay if you don't know. I don't expect you guys to know. I'll explain what it is after. Yeah, I see a lot of correct answers actually. So, capillary action is basically a process where a liquid, like water, it moves up something, right? Like a tube, and or into a material with lots of holes. So yeah, a lot of them, like a capillary tube, is a liquid moving up, or like water, uh, where water flows in like small spaces such as paper and it goes up. Yeah, that's correct. This happens when three forces called cohesion, adhesion, and surface tension work together. So basically, before you go into the experiment, you should like kind of research a little bit. So like yeah, that was around like three or so like, events this I mean like times this year had capillary action was on it. So that's definitely a big one that they ask for. Okay. So we're gonna start with part one, which is the design or construction of the experiment. The first thing is you have to first make up a statement of problem. And if you've done science fair before, this probably sounds familiar, where you have to like define the topic of the experiment and you have to find the relationship between two variables, the independent variable and the dependent variable being tested. So like how does the independent variable affect the dependent variable? Or what is the effect of independent variable on the dependent variable? On the top right hand corner of every slide, you'll see like I just screenshotted it from the rubric. So that's basically what you have to do in order to get full points. So we have to make sure that it's not a yes or no question. So the experiment I'll refer to in the experiment I'll refer to throughout this presentation is this one. How does the height a ball is dropped from, so like 1 to 3 meters, affect its rebound height, or centimeters? So that's the kind of experiment we'll be discussing. And then how about you guys all type in, make your own statement of problem, sort of using the format that I said here. There's no specific topic, so you can kind of talk about whatever you want to talk about, but make sure there's an independent variable and a dependent variable. And I'll get into that later, but it's the statement of problem comes first always, so I can't really say what it is yet. But yeah, if you know what it is, you can type it in. Yeah, how does the amount of water affect its boiling point? How does the amount of water affect the plant's height? Yeah, those are really good ones. How will the amount of heat affect the water's temperature? Yeah, those are good ones. So we have to make sure that the effect is there. It's something affecting something else. That's the kind of the main thing for this. Um, Actually, I would say bagels are better than donuts. Okay. Okay, so hypothesis is a proposed explanation or generalization on um, or like a trial. So it basically has to be tested by scientific research, which will be your experiment. So if I change the independent variable, then the dependent variable will be something else. So like what changes and in which direction? Because the rationale is very important. You can see in the rubric on the right hand side, it says 2 points. A rationale is given for the hypothesis. So that's very important. So here's an example from the same rebound height statement of problem I said in the previous slide. But here, look how it says, if I drop a ball from different heights, 1, 2, or 3 meters, then the rebound heights in centimeters for the higher drop heights will be greater than the lower drop heights because of Isaac Newton's third law. Now, the Isaac Newton's third law will be considered your rationale because it's like a justification of why you made this hypothesis, which is very important. So, yeah, this law applies to this experiment because when the drop height is greater, there is more force in the action of the ball falling to the floor, and thus the rebound height, or the equal and opposite reaction, will be greater. So I think the main thing I want to take away from this slide is the rationale. Because without the rationale, then you're just making a statement and you're not backing up for anything. So type in chat, what is the rationale? Like a general definition of what a rationale is. So in this case, it would be Newton's third law, but what exactly is it? Yeah, the reason. It's like a justifications or reasons for your hypothesis. Yeah, the reason in scientific terms, definitely. Okay. So next thing is variables. The independent variable is the variable that is changed during the experiment to examine the effect on the dependent variable. We must have 3 levels, and in our experiment, the drop height, 1 meter, 2 meters, and 3 meters would be your 3 levels. Your dependent variable is what is affected or what is being measured in the experiment. This does not include levels because something is being affected, so it's just one thing. And notice how each the independent variable and the dependent variable have units. Units are very important for the dependent variable and independent variable. The controlled variable is where the factors is like the factors which could affect the dependent variable, um, but are kept constant. So in our case, it would be like the size of ball, material of ball, shape of ball, like that. So basically, you could change the size of ball or the material of ball, but in our experiment, we're keeping those constant. Constants cannot be changed because it cannot be controlled. So like the Earth's gravitational acceleration, 9.8 meters per second square, we cannot change that. That's why it's a constant. Okay. So type in chat, what's the difference between a controlled variable and a constant? Yeah, you cannot control a constant, but you can control a controlled variable. Yeah. Yeah, all of you guys got it. Okay, moving on. Materials. So this is probably the most simplest section of the write-up. It's just items used to conduct the experiment, and it should be as specific as possible and quantifiable. So So for example, for our project, we're gonna need 3 pen racquetballs and 3 meter sticks. So notice how they used the number 3, and we used like the specific type of racquetballs, and it being pen racquetballs. This is very important. It says here in the rubric, all materials are listed and quantified. So we need to make sure we quantify it, and we don't just say racquetballs or meter sticks. So how about you guys type in chat a quantifiable material? It can be anything, but make sure it is quantifiable. So a cat won't be, it won't be quantifiable. We want like it's like a number. It has to have like a value of it. Or like a steak would work, but it needs to have like an actual like number in front of it. Otherwise, it won't be quantifiable. Yeah, 4 rubber bands, 5 ping pong balls, 1 dog. Yep, yeah, that's basically it. You make sure it's quantifiable. Even if it's like the most, even if it's like even if it's like a ruler, we need to say how many rulers. Otherwise, like just quantify everything for materials. Okay. Procedure or procedure and setup diagram. So procedure is a list of steps of an experiment, and the setup diagrams are labeled diagrams on how your experiment was performed. So for a rubric, it has to be procedure is presented in list form, logical sequence. So as you can see here, this is list form, and it's in a logical sequence. We're gathering the materials first, and we're cleaning up at the end. And the rubric, it also says steps for repeated trials are included. So that's why I bolted it. We need to make sure we say when we're repeating the steps. So repeat steps 2 to 3 twice more, or repeat steps 5 to 6 twice more. Twice more, yeah. So that's very important to put. And then for this, we had to put multiple diagrams of setup are provided. So for the setup diagrams here are not actually for this experiment, it's for another experiment, but you kind of get the idea of how you have to label everything and draw it in like a and draw it in like an appropriate way. Yeah, that's basically procedure. Okay, qualitative observations are when we use our senses. So like um, touch, sight, smell, using our senses to observe results or collect data. We must have an observation about the we must have an observation about the procedure and about the results. So you can see the rubric, it says observations about procedure provided and observations about the results provided. So that's kind of why this graph was made. You can see like there's a section for procedure and there's a section for results. So we say what is before, what is during, and what is after. We can't say what is before the results because there's nothing to say about. And then the observations are given throughout the course of the experiment, which is why it says before, during, and after. So whenever we're making qualitative observations, it's kind of a good idea to make this kind of table because you're basically following exactly what the rubric is telling you to do, so you won't miss any points. Yeah, there is a Kahoot at the end if we have time for that, which I think we will. Okay. Okay, quantitative data or the data table. So it's a way to organize numerical data, and you have to remember the units and titles. So you can see in like any one of the tables here, they all have units, and they all have. Okay, well this one doesn't have a title, but it's supposed to have a title, and we have to give sample calculation. So you can see where the arrow is pointing to, we have a sample calculation for average. So it's like x1 plus x2 divided by the number of values. And we give like a sample calculations because in the rubric, you can see here, example calculations for derived variables are given. So that's like 2 points, easy 2 points, and something that we should not miss. We included multiple trials. So you can see here trial 1, trial 2, trial 3, which is very important because we need to have like a variety of data that we can calculate averages from. Okay. Okay, so we're on part 2 now. That's basically part 1. During regular times when it's not virtual, you would have 20 minutes to complete. You would have 20 minutes to complete part 1 and the rest of the time to complete part 2. Okay, so first we're gonna do a graph based on the data we collected in part one, we have to draw a graph on it. It's just a way to visually represent our data. So these 1, 2, 3, 4, 5, 6 things are steps to just like completely ace the graph section. We first want to label our axis. Title our graph, and use the dependent variable as the y value. So the dependent variable earlier from the statement of problem, and the independent variable as the x value. We title each individual axis, connect the data points, or draw a line of best fit. We only include the averages of the data for each independent variable. If we included for every single trial, then our graph would be like way too big, and we don't actually have time for that to complete every section in 50 minutes. So you can see on our scatter plot the three averages written down for each drop height. And there's also a best fit line drawn. So a best fit line is basically a trend line that like that best illustrates the overall picture of what our collected data is showing. It basically helps us see if there's a relationship or correlation between the two factors, drop height and rebound height, being studied. That's basically the line there. And this is also an option that another person did. It was a bar graph. So you can kind of do whatever you'd like, whatever best represents your data. It's up to you. So, um, yeah, I actually agree. I don't think this is the best fit. It does need a bit of a slope because it's like starting a little late. But this was like computer made by someone else. So, yeah. Okay, with that being said, what is the line of best fit? So, what does the line of best fit even mean? Mm-hmm. Yeah, the line that best shows the relationship between the data points, basically the middle line, or the line that best represents the plot, definitely. Line that connects the data. Yeah, the ideal. That's a great one word to describe it. Yeah. Yeah, that's pretty much what the best fit line of best fit is. Okay. Moving on, statistics. So I'm pretty sure you guys all know how to calculate the common ones like mean, median, mode, and range. We also, like we did in the quantitative data, we have to give example calculations. You can see in the rubric, it's literally 4 points. We don't want to lose it. So just an give easy way to score points is just to give example calculations. So here you can see an example statistics chart drawn with the mean, median, mode, range, outlier, and standard deviation. Standard deviation is like when judges see it, they love seeing it. So like I would really recommend all of you guys to include standard deviation into it. Um, but yeah, this is how you calculate standard deviation. You take each value, subtract it from the mean, and then you square that, and then you get like a bunch of values. You sum it up, and you divide that by the number of values in the population. So yeah, I think you learn it in like algebra 2 or pre-calculus. Um, okay, how is standard deviation calculated? And it's okay if you don't remember, because like it's kind of hard at first. Like, okay, yeah, you learn it in pre-calc, but it's kind of hard at first. It's okay if you don't remember. I'll show it again, so it's fine. Just want to see if you remember. And I kept the symbols there if it helps you. Yeah, you don't remember? Yeah, that's fine. Okay. Okay, yeah. Just make sure before you go into like this event is you know how to calculate that, because it's like a really good bonus. Okay. Moving on. Okay, this is probably the section that everyone skips, but it's like the most major part for it. But it's analysis of claim, evidence, and reason. So what you want to do is you want to make a claim about your data, observations, and statistics. You want relevant, strong supporting evidence to back up your claim, and then you need reasoning for how your evidence backs up your claim. So if you can see the rubric, you can see it wants a CER for statistics, one for outliers, and one for data trend. You can see in the top right. So for statistics, in the statistics sections of CER, there are several ideas you can observe. So we have to make a claim, evidence, and reason for statistics. Then for outliers, you can try and force outliers into your data if you don't have one. Then you can talk about them here in other sections of the experimental analysis. Find data that you believe supports the fact that a certain data point is an outlier, then explain it in reason. And also, I'm pretty sure if you don't find any outliers, you can make a claim that there is no outliers and have evidence and reasoning to back that up. You also need a CR for um, you force outliers by like purposely kind of messing up your experiment. It's not the most like scientific thing to do, but to be honest, this part was from them. It's from Science Olympiad. So Science Olympiad was the one who told to um, force outliers into your data. Yeah, I'm pretty sure you if you want, you can use the outlier equation for evidence. Yeah, it's a great way to do it. For data trend, most data sets will end up with a data trend including some sort of correlation. So you can kind of use a graph to explain this. If there's like, that's why the line of best fit is very important. So like it shows like there's some sort of correlation, and we can use CR to explain that. Here's an example for our experiment of the CR. I don't expect you guys to read all this, but yeah, here it is just in case you want to give it a look. So yeah, you can notice how they talked about like outliers and yeah. If you don't have to do it in this format, you can also just do like CR statistics or yeah, you can screenshot it. Um, you don't have to do it in this format where they do paragraphs. You can also just be like claim blah 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 evidence so on and so forth. This is 18 points, so actually like it's like a definitely a really major one to take account for. Okay. Okay, possible experimental errors is where we examine the experiment and we have to identify two errors, like the rubric asks us to do. They want one specific error identified and its effect on results discussed, and then we need a second specific error identified and its effect on results discussed. Yeah, that's what we need to do. That's why it can be like a human error, it can be an experimental setup, and it can be um, written in a table or paragraph form, and I'll show you that. So typically, observations about the procedure are about noticing flaws in the experiment that went unnoticed before it was performed. So these can include flaws in measurement technique, flaws in building or maintaining an experimental unit, or flaws in the actual in performing the actual experiment. So these observations, qualitative observations about the procedure, carry over to this part where you explain what went wrong thoroughly, and you explain its effect on the results. This is also very important for practical applications. So this is actually okay. Here is the example. So you can see this is an example of a table one where they identified error one, error two, and this is an example of a paragraph kind of form of it. So possible experimental errors are often confused with qualitative observations, but the errors the errors in so the experimental errors must be precisely identified and their effects on the results must be discussed. But in qualitative observations, errors would just be merely observed. So they're actually not the same thing, and not all qualitative observations are actually due to errors. Okay. Okay. Yeah. Type in chat. What is the difference between qualitative observations and errors? So I think the major point to take across of this is qualitative observations. You just observe it basically, and it's it's like collecting data. But possible experimental errors are like kind of after you kind of do the experiment. So you need to include you need to include like you explain it more thoroughly, and you have to put the effect of this on the results. Um, yeah, and the errors are what went wrong. Yeah, errors are what went wrong. Qualitative observations are just observations. Okay. Okay. The conclusion is kind of more simpler than it looks. It's just basically a hypothesis CER. Like you can see in the rubric, it says the claim, evidence, and reasoning completed. So first, you want to say what your hypothesis was. You want to say like a claim about your hypothesis. Was it supported or was it not supported? Then you give your evidence, and your evidence should just basically just be your data from like the quantitative data or qualitative data, and then you should give your reasoning about why your evidence supports your claim. It should primarily be data based and what you have actually observed. So yeah, here's the conclusion for our experiment. If a ball is dropped from different heights, then the ball dropped at the greatest height will have a greater rebound height. The data supported this hypothesis with 1 meter drop heights averaging 81 centimeters. So they're giving concrete, like actual numerical data. 2 meters averaging about 163 centimeters, and 3 meters averaging about 222 centimeters. Also, the graph showed a positive trend that had greater rebound heights when the drop height was greater. From these clear reasons, the hypothesis was accepted. So, very simple, very short, but communicates a lot. Okay. So the last section is recommendations for future experimentation. So there's 3 questions you need to do. How can I improve for more accurate results? A practical application of this experiment, and future experiments that you can do relating to the dependent variable or the independent variable, where you like change it up a little bit to make it like a new experiment but like the same topic. So a practical application of this experiment would be like basketball and tennis. You can see in like the last paragraph down here, it basically shows that like how it is influenced, how it is used in basketball and in tennis, like the rebound height concept. Um, Another thing is a future experiment related to the dependent variable. So instead of measuring the rebound height like we did in this experiment, we could use the measured variable as how many times the ball bounces, or if you want to change up the independent variable, we could do like the size of the ball or the material of the ball, which is where the controlled variables come in place. So if you don't know what to write for the future experiment related to the dependent variable, you can kind of choose one of the control variables and adjust basically that. So yeah, those are the 3 things, just like the rubric says. Okay. Okay, so now it's Kahoot time. I'm gonna stop share and then share again. Okay. Uh, yeah, sorry. Yeah, I'm showing the answer choices. I'm sharing screen again. Um, okay. There is your pin. How do I move this? Grab it. Um, okay. Just give it like a minute for people to join. It's just 5 questions, so it's kind of short, but that's okay. Okay, I'm gonna start in like 15 seconds. Okay, yeah, 15 seconds. Thank you for reminding me. Okay, start. Okay, that was really short. I don't know why it had that time. Maybe I did something, but yeah. The next one that hopefully will be longer. Okay. Next. Yeah, it was false. They're not the same thing. We covered that. Okay. What should the qualitative observations be based on? Okay, it's procedure and results. So, so about this one, it's not the design and the procedure because like I showed in the slide, we need to do like the before, during, and after about like what happens during the procedure, and then the results, like the qualitative observations of the result. Because you can't really make a qualitative result on the design because like your design is like what your idea is. So there's not really much to observe about it.
Very on the podium. I don't understand. Get on chat.
Okay, let's keep on. Measuring devices are allowed in experimental design. True or false? Oh, this one's 20 seconds. That's okay. Yep, it is true. You can bring kind of any measuring device you want to like. It's really helpful. Yeah. In the conclusion, do you say the experiment showed my hypothesis was right or my hypothesis was supported by the data? Yeah, you have to say my hypothesis was supported by the data. You never say your hypothesis was right or wrong because, like, that's you just like don't. You kind of just say like if your hypothesis was not supported, you would just write my hypothesis was not supported as the data shows. Okay. Okay. Last one. What do I do if my experiment goes horribly? I didn't say this, but I feel like it should like I don't know. Maybe that answer is not too obvious, but I don't know. Yep. Focus on the report as much as possible. Yeah, I'm proud of you guys. Didn't sit there and do nothing. If it goes horribly wrong, making the experiment work is not gonna do anything, and and the judges don't care about if your experiment worked or not because the only thing that they see is your report. So you focus on the report as much as possible, and you wouldn't clean up the mess because you can literally do that after. Okay, let's see the final scores. Okay, yeah. Good job to everyone. And one thing I want to say is if you're a rising seventh grader and you go to Basis Independent Silicon Valley, and if you want to be part of the SO club next year, I can give you an email where you can like message them, and I think they'll do like an interview or something. But yeah, if you just want to do that, then yeah, you can do that. Let me find the email. But it's only for rising seventh graders because the rest of the spaces are actually full. I'm fine. And if you have any other questions, you can ask that. And then 2 minutes will be a break. Oh, if you're a third grader, I'm 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 proud of you for like understanding everything. Okay. Yes, we got so. No, no, no. It's for everyone. This is for everyone, but just for the people who are rising seventh graders, because we need more people for rising seventh graders, and the coach has instructed me to ask you guys. Um, and I cannot find the email. Okay, wait. Yeah, you guys can go for break. I'll just put the email in chat. Oh, this is okay. So Science Olympiad is basically you can choose kind of what events you want to do. So it's not just for this event or some other event. It's kind of like whatever you want. Um, uh, yeah. Yeah. You guys can go for a break now. Thank you for coming and listening.